Hello and welcome to Math IPREP Part 3, Practice Problems. So in this Part 3, we are going to go over some practice problems to kind of solidify the concepts that we learned in the lecture video. So we have a worksheet prepared, and we're going to go ahead and work through that together. So Section 1, Linear Equations, Anatomy of a Line. So fill in the blank. The slope-intercept form of a line is y equals mx plus b, where m is the blank and b is the blank. So what is m? That is going to be slope. And what is b? The y-intercept. So an intercept is where the line crosses the axis. So the y-intercept is where it crosses the y-axis, and the x-intercept is where it crosses the x-axis. So if you remember, here are axes. Up and down is y, left to right is x. So you can find x-intercepts by plugging in 0 for y, and you can find y-intercepts by plugging in 0 for x, or by looking at the y-intercept notation. So it's either going to be b in an equation like this, or you can just plug in 0 for x. So here's an example. 8y is equal to 4x plus 8. When you rearrange and solve, we get y equals half of x plus 1. So then we know y equals mx plus b. We have our slope of 1/2, our y-intercept of 1. And then the way we find our x-intercept is we set y to 0. So it'll be y equals half of x plus 1. Should say 1/2 of x. Anyways, or it's a different one. But yeah, so we have 0 equals x plus 1. We solve for x. And then here we have so let me practice some more. Let's look at some problems. So first we have y equals 3x plus 2. So what is the slope of this problem? And remember, slope-intercept form, we have y equals mx plus b. So y equals mx plus b. So slope is equal to 3. What's the y-intercept? Remember, it's b. So it's going to be 2. So y-intercept 2. And for the x-intercept, we set y to 0. So we do 0 equals 3x plus 2. And then we just solve for x. So we do -2 minus 2. So -2 is equal to 3x divided by 3 divided by 3. The x-intercept is equal to -2 divided by 3, or -2/3. So see how we did that? So our y-intercept is from our equation, our slope is from our equation, and then our x-intercept, we set y to 0, and then we just solve for x. So we have to subtract 2 from both sides. That gives us -2 equals 3x divided by 3, and that gives us -2/3. Let's go ahead and try another one. So here we have y equals 2x minus 4. So what is the slope of this equation? It's 2, right? Because y equals mx plus 4, or I'm sorry, minus 4. So m will equal 2. So next we look at our y-intercept. Here we have 2x minus 4. So what's our y-intercept? Well, -4, right? Because it's -4. So -4. So finally, we can look for our x-intercept. And to do that, remember, we set our y value to 0. 0 equals 1/2 x plus 5/2. Oh, sorry, I carried carried away. Looked at the wrong one. It's 2x minus 4. So then to solve this, we have to get rid of this 4. So plus 4 plus 4. So we have 4 is equal to 2x. I'm going to divide 2. X is equal to 2. We have our slope, our y-intercept, and our x-intercept. So now let's go ahead and move on and do another one. Let's choose one a little bit harder. I like the next one, so we're gonna go ahead and do this one. And then we'll go ahead and do this one. And then we'll do 3 of these, and then we'll move on to the next section. So first we have y equals 1/2 of x plus 5 over 2. So first, what is the slope? Y equals mx plus b, it's m. M equals 1/2. Then we have our y-intercept. Equals 5 over 2. And for our x-intercept, we set y to 0. And we just solve for x. So first we subtract. So we have negative 5 over 2 equals 1/2 of x. So we go divided by 1/2, divided by 1/2. Remember how we do division of fractions? We do same, switch, flip, right? Negative 5 over 2 times 2 over 1 equal 10 over 2. It's not a good 2 at all. It's equal to negative 5. So that's our x-intercept, it's negative 5, our y-intercept is 5/2, and our slope is 1/2. So then we'll do E. Oh, that's not that color. 2y is equal to 2/5 of x plus 8. So what would be our first step? What is our slope? So if you're not careful, you might say 2/5. But if we look closely, this is not in slope-intercept form because it's not y equals mx plus b, it's 2y. So we have to divide this by 2, divide all of that by 2, and that's going to give us a whole new equation to work with. So we have 2 divided by 2 is equal to 1, so 1y. 2/5 divided by 2 is 1/5. And then 8 divided by 2 is 4. So here's our equation. And now, whatever we find here will be our answer. So what's our slope? 1/5. What is our y-intercept? And remember, we can put y-intercept as b because y equals mx plus b. So b, or our y-intercept, is equal to 4. And then we have to find our x-intercept. Remember how we find that? We plug in y for 0. So 0 equals 1/5 of x plus 4. Do minus 4 is 4. Negative 4 is equal to 1/5 x divided by 1/5 divided by 1/5. So -4 divided by 1/5 of -4 equal to -20 equals x. So the x-intercept is going to be -20. Our y-intercept is 4. And our slope is 1/5. Let's go ahead and try one more. And this time we will do h. All right, so what is our slope? At first, we can think, can we put this in a slope-intercept form? And I think we can, right? So first, we have to get rid of this 20. So we'll do -20 to both sides. That gives us 4y is equal to 8x minus 20. We see we do this whole thing divided by 4. So we get y is equal to 2x minus 5. And once we have it here, it's a lot easier to work with, right? So what's our slope? And y equals mx plus b. Our slope is m. So our slope is going to be 2. What is our y-intercept? -5. Remember, because it's 2x minus 5, so we have to do -5. Then how do we find our x-intercept? We plug in 0 for y. So 0 is equal to 2x minus 5. Solve for x, so do +5 to both sides. So 5 equals 2x divided by 2. So we have 5/2 equal to x. So if you have any questions on this, go ahead. You can watch our lecture that we had on part 3, or you can rewatch this part of the video. We'll go ahead and move on to the next part. So just a quick note about our lines. We are used to seeing our lines in y equals mx plus b, and this is known as slope-intercept form. But this is not the only way that we can have lines. So here are some examples of that. So first, we see we have something called point slope form, which will look like y minus y1 is equal to mx minus x1, where x1, y1 is a point on the line. And if you want an example of this, it's right here, part I. So next we have standard form, and that's going to be ax plus by equals c. And then we see that right here, right? ax plus by equals c. It might be backwards, but it is the same thing. So those are some examples of different types of lines and equations we can see. But something to note is you can rewrite all of these equations to fit any of these forms. So you can turn a slope-intercept into point slope into standard, and vice versa. And all 3 equations you'll end up getting equal the same line. If you plot all 3 of them, you'll get the same line on all 3. So let's move to parallel versus perpendicular. So parallel versus perpendicular. Parallel lines run next to each other and never touch. So here we'll draw 2 lines that are parallel. Right. So these 2 lines will never touch, right? If they kept going forever and ever and ever, they would still never cross. So perpendicular lines cross at a right angle. So draw 2 lines that are perpendicular. So here we have 2 lines that cross at a right angle. So the degree of this angle right here is going to be 90, and so on all the way around. The way we show right angles, to draw a little box in the corner. Parallel lines have identical slopes, while perpendicular lines have slopes that are opposite signs and are reciprocals of each other. So let's look at an example of what that means. So if one line has a slope of 1/2, so let's say this line has a slope of 1/2. Does the line next to it have the same slope or a different slope? Let's say it's the same, right? everyone that this one goes over and up, the other line does the same because they are parallel to each other. So if our slope has a line of 1/2, a parallel line would have a slope of 1/2. So if a line has a slope of 1/2, what slope would a perpendicular line have? And here's some better examples of that. So here are two perpendicular lines out of, the slope of 1/2. Here we have a perpendicular line. So we have this with a slope of 1/2. We see it's the opposite reciprocal. So if it's 1/2, then that is the slope of our perpendicular line. That line that crosses over at a right angle. So 1/2 to -2/1. So as you can see, you flip it and you change the sign. So you are given an equation for a line. Let's move on to this next part really quick. You're given an equation for a line. Let's say y equals 2x plus 2. How many possible equations for a line could you write that are parallel to it? So let's say infinity, right? We can see by drawing this out, right? So that's a line. This one is parallel. That one's also parallel. Oh, and so is that one, right? None of these lines are ever going to cross each other. So they're all parallel lines. So they all have a slope of 2. Now the difference is going to be this right here, the intercept, right? So if we have that is our lines, you see they're all going to cross this y-axis at a different point. So this first one might be +2. The second one might be +0, so just y equals 2x. This one might be -2, so y equals -2x, and so on. So now what about lines that are perpendicular? So if you have this line right here, how many lines could you draw that are perpendicular to that line? I would say infinite, right? Because you can do one there, one there, one there. You kind of just see how we could do that forever and ever, right? So let's say this line, if it had a slope of 2x plus 2, maybe this line is going to be negative 1/2 of x, maybe -4. And this one right here is going to be -1/2 of x -8, and so on, right? So we can make infinite other equations that are perpendicular or parallel to any line because numbers are infinite and graphs go on forever and ever if we want them to. So let's do some practice. So here we have our initial lines, and we're going to do some equations of parallel and perpendicular. So this first one, we have y equals 5x plus 4. What is an equation that's parallel? So remember, parallel is going to have identical slope. So we have y equals 5x. This one also has to be y equals 5x. Now the difference is that y-intercept. So this one's +4. We could do -23. Now what about a perpendicular? Remember what changes here? The slope is the opposite reciprocal. So from 5x, it becomes -1/5x. Our y-intercepts can be the same or different. So this one, we'll say it's the same, +4. So now we have another line, y equals -3/2 of x plus 3. What is an equation of a parallel line to this? Well, let's make sure that our slope stays the same for our parallel line. So y equals -3/2 of x. And what changes is this, right? So we have +3. Let's do +4, right? We're not going to change it that much this time, just a little bit. But that's still a parallel line. So here we have to do perpendicular. So remember what we do with our slope. We do opposite reciprocal. So from -3/2, we go to +2/3. And our y-intercept can be anything. So if it's +3 over here, we can do +903. It doesn't matter. This is still going to be a perpendicular line to our original line. So let's do another one. Let's do D. So here we have y equals x. So what is the equation of a parallel line? So our slope has to be the same. So what's our slope here? Y equals x. What is m? Well, if we don't see it, that means m is 1. So we keep x the same. And then we need to change our y-intercept. So right now, what's our y-intercept? It's nothing, so it's going to be 0. So we can do whatever we want here. So you can do -3. Or any number, right? So y equals x minus 3. These are parallel lines. Now let's look at perpendicular lines. So we have y equals x. So what's the reciprocal of 1? We have 1 over 1 equals -1 over 1 equals -1. So y equals -x. And then again, we can do whatever we want with the intercept. So let's say it's the same, -3. Cool. So let's go ahead and do one more of these. Wrote this one right here. Y is equal to 0.25 of x plus 0.5. So here we have our line, we have our slope, we have our y-intercept. So for our parallel line, we just keep our slope the same. So y equals 0.25 of x. The thing we change is our y-intercept. So this is plus 0.5. So we can do whatever we want. Let's say we do plus 6. So these are going to be parallel lines. So now let's look at a perpendicular line. So we have 0.25. Now we need to change that into a inverse and opposite sign, which is kind of hard to do when we have a decimal, right? So one thing we can do is we can turn this decimal into a fraction. So we have 0.25. To turn it into a fraction, we divide this by 100. So we have 25 over 100, which is equal to 1 over 4. So then our opposite reciprocal would be -4 over 1 or just -4. So we have y is equal to -4. And then again, we can do whatever we want for our y-intercept. It can be plus 0.5, it can be plus 6, or it can be something like minus, or it could even be 0. We could just leave it like that, y equals -4x. And this will be a perpendicular line. Our y-intercept is just 0. So if we wrote that out, it would be plus 0. But we don't write that. So those are some examples of our lines, parallel lines, and perpendicular lines. So let's go ahead and move on to the next section. So identify the equation of the line. A line's slope explains how steep a line's incline is. So as we talked about in the lecture earlier, if we have a very high number as our slope, we're going to have a very steep line. If we have a very low number, it's going to be not as steep. So slope has an equation of y2 minus y1 over x2 minus x1, where x2, y2, and x1, y1 are points on the line. This is also called rise over run, because it talks about how far up the line goes compared to how far it goes horizontally at the same time. So for an example, if you have a line that goes to the points 3, 2, and 5, 8, the slope of a line is 3. And here's how we calculate that. So we take our bigger number for y, so y2, or sorry, one that's further down on the x-axis. So if we have x3 and x5, we know 5 is to the right of 3 on a graph. So 5, 8 will be our x2, y2 coordinates. So we just plug it all in. So we have 8 minus 2 over 5 minus 3 equals 6 over 2. Again. Just to say where we got those numbers from. And then we get a slope of 3. So now let's try finding the slope. So we have a line that passes through 4, 2 and 8, 1. So this one, we know 8 is larger than 4, so it's to the right. So I have 8 over 1. And we take these, right? We have x2. Oh, and I did this wrong, sorry, it's backwards. Remember, it's rise over run. So rise implies up and down. x side to side. So rise over run, we have 1/8. And then we look at our other numbers, 4, 2. So 1 minus 2, 8 minus 4 equals -1/4. So our slope is -1/4. That's simple. Let's go ahead and try it again. So here we have a line that intersects 1, 2, and 2, 4. So we take rise over run. So rise on top. So we have 4 over, myself some more room. 4 over 2 minus 2 minus 1 is equal to 2 over 1 equals 2. All right, let's try one more. We'll do 2 more. So here we have a line that has an x-intercept of x equals 3 and a y-intercept of y equals 4. So what does this tell us? If we need 2 points, we have these. What coordinates? If we have an x-intercept of x equals 3, it tells us we have coordinates of 3, 0. If we have a y-intercept of 4, 0, if y equals 4, then we know it's 0, 4. So now we have 2 points, and we can do our equation. So we have 0 over 3, 0 minus 4, 3 minus 0. We have -4 over 3. And that is part C. Now we can do one more. We have D, a line that intersects the origin and 820. So what is the origin? We have a graph. It's right in the middle. So 0, 0. So now we can think about what this line looks like. So we have our 2 coordinates and our 1 coordinates. So we can do rise over run. So 20 minus 0 over 8 minus 0 equals 20 over 8 equals 5 over 2. And that is our slope. So that's a slope for all 4 of our problems here. Let's go ahead and move on. So here we have some graphs to look at. So we'll look at these bottom 2. So how do we find the slope? So we pick 2 points, and then we just do that from there. So first, we have this point here, and we have this point here. So our points here, we have 0, 2, 0, 2, and over here we have, 0, 1. And over here we have 2, 0. And then we just plug in our rise over run. So we still do the same math we've been doing. So 0 minus 1, 2 minus 0 equals -1/2. So in other words, our slope is -1/2. For every 1 it goes over, it goes down 1/2. So here you were at 0, 1. So if we go over 1, yep, that we go down by half. If we go over another 1, down by another half. So you can also confirm your results just by looking at the graph. So let's try another one. So here we have our intercepts. We have 0, 3 and 4, 0. And we can just go ahead and plug in our equations, right? 0 minus 3, 4 minus 0, -3 over 4. So those are our problems, and those are our solutions. So now let's go ahead and move on to writing the whole equation based on these. So let's go ahead and do A first. So we have, write the equation for a line in slope-intercept form. A line that passes through 4, 2, and 8, 1. So first, let's find our slope. So we find our slope by rise over run. So we have 1 minus 2 over 8 minus 4 equals negative 1 over 4. So negative 1/4. So now we have part of the puzzle, right? Y equals negative 1/4 of x. So how do we find our y-intercept? We set x to 0. So let's go ahead and set x to 0. Oh, wait, never mind. That only works if we already have it. That's how we can definitely check it. But let's also keep going. So 4, 2, and 8, 1. So we know our slope is negative 1 over 4. So for every 1 it goes over, it goes down 1/4. Or for every 4 it goes over, it goes down 1. So over 4, down 1. So we look at our points, we can kind of see how we get there. So if we have at 4, we have 2. At 8, we have 1. And at 12, we have 0. All right, so that's our x-intercept. Let's go the other way. 4, 8, 12, 8, 4, 0, 0, 1, 2, 3. So without graphing, just using some algebra, we can see 0, 3 is going to be our y-intercept. So this is plus 3. 1 equals negative 1/4 of x plus 3. So now let's look at a line that might be a little bit easier. Let's look at this C. So we have a line that has an x-intercept of x equals 3 and a y-intercept of y equals 4. So our x-intercept is 3, 0. Our y-intercept is 0, 4. So already we have a y-intercept, right? We don't even have to do this one mathematically. It tells us in the answer. So plus 4. And then we can just do rise over run. So 3, 0, we have 0 minus 4, 0, 3, 3 minus 0 equals negative 4 over 3. So those are some answers for C and for A. So now let's go ahead and let's find some different ones. So we'll do D and we'll also do E. So first, what is our slope? So this is the origin and 8 over 20. So we see our slope is going to be 20 minus 0 over 8 minus 0. 20 over 8 equals divided by 4, 5 over 2. 5 over 2x. And then for our y-intercept, this is where the graph is really nice. We can just look. Where does it go over the y-axis? Right there. So plus 2. So that's all it takes. That is our equation for this line right here. Cool. So let's move on to part E. So we have our line. Let's find our equation. So we have a y-intercept of 0, 1. And we have an x-intercept of 2, 0. So already we have y equals something x plus b, and we know b is going to be 1. We can see that from our graph. Then we just need to find our rise over run. So we have 0 minus 1 over 2 minus 0 equals negative 1 half. Negative 1. So there's our equation for the line to the left. So good job. Now we'll go ahead and move on to the next section. So in section 2, we're going to deal with graphing. So we found the equation from the graph. Now we're going to find the graph from the equation. So the slope of a line is nicknamed rise over run because it dictates how far up a line goes in respect to how far horizontally it goes. A slope is y2 minus y1 over x2 minus x1, where x2, y2, and x1, y1 are points on the line. B is the y-intercept, which, as we've been talking about, is where the line crosses the y-axis. In order to graph a line, you must have the line cross the y-axis at the correct location and have the correct slope. So here are the steps to draw a line. First, you'll draw your axes. So it's these right here, right? Your 0, 1, 2, 3, 4, and so on. So you draw those axes. Then you label them. Do they have increments of 1, 5, 10, 100, etc.? Next, you'll draw a dot at the y-axis. Then you'll count the rise and run and put another dot at the second location. All you got to do now is draw a line through all your dots. Then you can label it with your equation, and you can check. And here are a couple of things to check. If your slope is positive or negative in the equation, it should be the same thing when you graph it. So if it's positive 2, as in the one below, we have 2x plus 5. You see that it's positive 2, and the line goes up and to the right. So then we look, is our slope large or small? So 2, we're going to have a decently inclined line, and we see that it does. And then are our intercepts the same, and is the line labeled? So the intercept we have here, 0, 5. We see that matches y equals 2x plus 5. You could also circle them. That's something else they could have done here, right? They could circle here my y-intercepts. Here's my x-intercept, here's my y-intercept. But that is optional. All right, so let's go ahead and do some examples together. So first, I have y equals 3x plus 2. A line through the middle, a line across, and then we are going to say that this is going to go by increments of 1 and by increments of 1. So in other words, every box is only 1 point. So now we just have to draw. So first, a nice easy point to start with is our y-intercept. So if we have y equals 3x plus 2, we have plus 2, we know we can graph at 0, 2. Let's go ahead and put a point at 0, 2. And then we just use our slope to find another point, right? Or we can plug in x. So I'll do this example, we'll use the slope to count, and on the next example, we will show plugging in a point for x. So here we have a slope of 3, which means every 1 we go over, we go up by 3. So here we go 1 over, up, 1, 2, 3. That's our second point. Now, if you'd like, we can do it again. Go over 1, up 3, and so on. All you have to do here is just draw a line. All right, so that is our line. So that is how we draw. And then if you want, you can put as well y equals 3x plus 2. Put some arrows here just to show that that keeps going. Awesome. So now let's go ahead and do the next one. So here we have y is equal to 2x minus 4. So first thing we do is we draw our axes. All right, and then we draw our points. So our first point is our y-intercept. So 2x minus 4. No, it's minus 4. So it's going to be 0, 1, 2, 3, minus 4. So now here's what I mean, but we can do it mathematically. So let's say we want to see what is it at 2. So x equals 2. So we do y is equal to 2 minus 4. So we just plug in x equals 4 minus 4. Y is equal to 0. So that's at 2, it's equal to 0. And if we want to check with our other method of going up 2 over 1, we can do that, and we see that it works. All we have to do is just connect our dots and connect our dots. And there we go. We have graphed our second line. Let's go ahead and move on and try a couple more. Cool. So in this one, we have y equals 1/2 of x plus 5/2. So we can do here, 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 here. Now here's something different, right? So we see our slope is 1/2 and our x-intercept is 5/2. So if we want to do something a little different, we can do this by increments of 1/2. This tells us every square is equal to 1/2. Okay. So now we draw our points as normal. So first we have our x-intercept or our y-intercept of 5/2. So it's 0, 1, 2, 3, 4, 5/2. And then we go and we find different lines. So we can either do this with our slope or by plugging in. So let's go ahead, we can plug in, let's say 2. So if y equals 1/2 2 plus 5 over 2. And then we just solve for y. So equals 1/2 of 2 is equal to 1 plus 5/2 is equal to 7/2. Or 3.5. Whichever one's easier for you. So then at 2, we go 1, 2, and then we go up 7/2, 1. Or sorry, this is 2, and we know each is half, so we go over 4, right? 1, 2, 3, 4, 1/2, 1 whole, 1.5, 2. Then we go up to 7/2, 1, 2, 3, 4, 5, 6, 7. And then we just connect the lines. Something you'll notice is that the method is going to be the same regardless of your increments. So we see that on our other ones, each box was worth 1, right? But on this one, each box is only worth 1/2. But if we try to do this, it's going to be the same, right? So 1/2 slope means for every 1 up, we go over 2, right? So we go up 1 over 2. So we see that's correct. Rise over run. We rise 1 and we run 2. So you can either count it or use this plug-in method as we've been doing. All right, so let's move on. If you want to do some more, here's an example you can do. Here's some equations you can work with. Here are a couple more. 3x plus 3, 24, 36 plus 70. So you can feel free to take pictures, try this on your own paper. But we're going to go ahead and move on to word problems. So we have 2 word problems to do, and we're going to have a problem, and then we're going to figure out an equation for that problem and then graph it. So some variables have a linear relationship where knowing the value of one allows you to predict the value of another. In such equations or situations, you can write an equation of the line to graph the relationship to solve for the value of either variable. So when using x and y, the variable x is the independent variable and the variable y is the dependent variable that differs due to the change in x. So an example, How much money you pay for a plumber to fix your sink depends directly on how long it takes them. So in an example where a plumber charges $35 an hour and a fee of $20, we can use an equation to represent the relationship between costs and hours. So we have y equals 35x plus 20, where y is the price and x is the number of hours. So if you wanted to, we could also graph that. We're not going to right now, but we are going to graph this next problem. So here's the problem that we get to work with. A factory makes 100 books for every cartridge of ink they put in the printer. Write an equation for the relationship between books and ink cartridges. So as we talked about earlier, x is going to be our independent and y is dependent. So if you have every cartridge makes 100 books, that means your cartridge is going to be your independent. Without the cartridge, you can't have any books, right? So independent. And then our y value is going to be our dependent value. As we just talked about, our dependent is our number of books. And our independent is our cartridges. So when we write this out, we have our equation. We have y is equal, and then how many books do we get per cartridge? 100. 100x. And do we start out with any books? I don't think so. So that's it. We don't have a y-intercept. If we don't have any ink, we have no books. Right? So if x is 0, y is also 0. So y equals 100x. That is our equation. So now we can plug this in. If 8 cartridges of ink are produced or put in the printer, how many books can be produced? So you just plug this in. So y is equal to 100. And we know x is our cartridges. So we plug in x, 8. What's 100 times 8? 800 books. So we have 8 cartridges of ink, we get 800 books. So if 300 books are produced during the week, how many cartridges of ink did the factory use? So now we have a y value, right? Because we have the books, but we don't know how many cartridges. So we plug in y. We have 300 equal to 100x. We just solve for x. So we can divide by 100, divide by 100. And when we do that, we get x is equal to 3. So we have 300 books. We have 3 cartridges of ink. Cool. So we now have an equation. We see that it works both ways. We can figure out books or ink based on each other. And now we can also graph it. So for every 1 cartridge, we have 100 books. So already we can think we might have a different value for our grid going each direction. So going x and y, or sorry, x side to side, we might have a value of 1. Every square is worth 1. But going up and down, we might have a value of 100. Right? Remember, this is our x, this is our y. So now let's plot some points. So first, we know we have a y-intercept of 0, so we have a point at 0, 0. If we have no ink, right? If we have no cartridges, we have no books. But if we have every cartridge we have is 100 books, so we go over 1, up 100, which for us is 1 square. And we know for every 1 over, we go up 100. We can just walk this up. And then remember, all we have to do is just connect our lines. And there you go. So we have our equation, y equals 100x. We have our lines, and we are good to go. So that is the first problem. Let's go ahead and move on to part 2. So in this problem, we have a horse, and we have some hay. So a horse eats half a pound of hay every hour of the day and night, and 5 pounds of hay right after you feed it in the morning. So for every hour, he's eating half a pound of hay. And every morning, so let's say every 1 day, he's an additional 5 pounds. So let's write an equation. So first, we have to identify our variables. So we have x, which is independent, and we have y, which is dependent. So we have pounds of hay, and we have hours, right? For every 1 hour, we have half a pound. So hours is what we're working with here. And then we have every day we get 5 pounds, right? So in this problem, we're only going to deal with 1 day at a time. So we're not dealing with more than 1 day. So this is also going to be our y-intercept, or b, right? Because even if you're only there for 5 seconds in the morning, or you only feed it for 1 hour, it gets 5 pounds. Cool. So our dependent variable is going to be pounds of hay. And our independent variable is going to be hours. So when we write our equation, so y equals pounds of hay. Now let's think. What is it going to be our slope? So if x is hours, for every hour, what happens with our pounds? It goes up by 1/2. So our slope's 1/2. Y equals 1/2 of x. And what's our y-intercept? Y equals 1/2 of x plus 5. So now let's do a problem and plug it in. If you see that 7 pounds of hay have been eaten, how many hours has it been since you fed your horse? So 7 pounds of hay. So remember, y is our pounds, so just plug it in. 7 is equal to 1/2 of x plus 5. And then we just solve. So minus 5 minus 5. So we have 2 is equal to 1/2 of x divided by 1/2. X is equal to 4 hours. So for 7 pounds of hay, it's been 4 hours, right? Because we started with 5. Every hour is a half a pound. So it's been 4 hours to add 2 pounds. So in the other way around, if it's been 6 hours after you fed the horse, how many pounds of hay do you think have been eaten? So this time we plug in hours, right? So we have y is equal to 1/2 in 6 hours plus 5. 1/2 of 6 is 3. 3 plus 5 is 8. So y is equal to 8. So if it's been 6 hours, 8 pounds of hay have most likely been eaten. So now let's go ahead and let's graph this out. So first, we draw our axes. And we label them. What's our graph? I think this time we're going to go back to 1. So every one block up is a value of 1. Every one block left or right is also a value of 1. Then we just graph some stuff, right? So we have y equals 1/2. Y is equal to 1/2 of x plus 5. So what is our y-intercept? It's 0, 5, right? So 0, 1, 2, 3, 4, 5. And then all we're doing is counting. So if we have 1/2, that means for every one up, it goes over 2, because rise over run, right? So up 1 over 2, up 1 over 2. Or if you're going to do it the other way, we can always plug stuff in, right? So if we plug in, let's say 3, or no, it's not something, let's say 4, right? What's 1/2 of 4? 2 plus 5 equals 7. So we could do 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Look at that. Now all I got to do is connect our lines. So that is it. That's all we have for part 3 practice problems. So thank you for working through this worksheet with me. I hope it was helpful. And again, feel free to go back through the video and review any problems that you struggled with. There's also those extra ones that we did not go over that you can go over by yourself. So thank you for coming again. I hope you check out more of our videos. We also have part 4 and also parts 2 and 1 if you haven't seen those yet, and practice problems with all of those. Thank you. Hope you have a great day. Bye.